Hi everyone, so now we're going to be talking about sums of arithmetic series, and the big difference between arithmetic series and arithmetic sequences is that a series has a stopping point. There's only so many terms, it doesn't go on forever and ever, whereas sequence, like we were talking about in the last self-check, or last video, could potentially go on forever and ever. So the cool thing about arithmetic series, the ones that stop, are that we can sum them up or find the sum of them. And so this is how this video is all about how we can find those sums. So there's two different formulas we can use to find the sums of arithmetic series, and I've written them down right here. So the first one is S sub n, and S sub n just stands for the sum is equal to n, which remember is the term, like how many terms we have in this case, times a1 plus an, which is the first term and the last term, all divided by 2. Or we could use the second equation, which is S sub n is equal to n times 2 times a1 plus d times n minus 1, all divided by 2. So either of these equations work, and really you get to decide which equation you want to use, and it's best to kind of look at what information you've been given and then decide the equation, because some of the questions that you might get won't have the same information. So let's start with the first example. The first example gives me that a sub 1, which is my first term, is equal to 9. A sub n, which is my last term, is 165. And then n, which is how many terms I have, is 40. So if I'm looking at the two different equations and what I have, because I have a1, an, and n, I'm going to use the first equation. I'm going to just rewrite it down here. S sub n is equal to n times a1 plus an, all divided by 2, because I have all of that information. Whereas for the second equation, I would need to know what d is or our common differences, and I wasn't given that. Excuse me. Potentially I could figure out what that is, but this is easier. I can just plug everything that I already have into a different formula, into my first formula, and get an answer. So when I plug this in, I'm going to have S sub n, which we know n is 40, right? So I can change it to S sub 40 is equal to n, which I know, once again, is 40, times a sub 1, which is 9, plus a sub n, which is 165, all divided by 2. And now all I have to do is plug that in to my calculator, which gives me that the sum of the first 40 terms of this series is 3,480. And that's my answer. Okay, now let's look at the second example. And the second example gives me the information that a sub 1 is equal to 17, d is equal to 7, and n is equal to 50. So in this case, once again, we're going to look at the two equations we have and decide which one's going to be the easiest to use, or what information I have, which equation I can use based on the information that I have. So in this case, because I wasn't given an a sub n, I can't use that first equation. Potentially I could find a sub n, which is totally fine, but it's going to be way easier to use the second equation because I already have all of that information. So I'm going to just write that second equation down here. All right, so now let's just plug in everything that we know. So we have S sub 50, because n is 50. So that's the sum of the first 50 terms is equal to 50. Then in parentheses, 2 times a1, which is 17. And I'm going to put that 17 in parentheses there just so I can kind of differentiate it between the number 2. And then plus d, which is 7, times n minus 1. So that's 50 minus 1. All divided by 2. And now we can just plug that, oh, that looks like a 5. That sucker in, which would give us 1,193. And so the sum of the first 50 terms of this series is 1,193. All right, let's look at the third example. The third example actually gives us the same information as the second example. So automatically, I know I'm going to have to use that second equation because I don't have that a sub n for the first equation. So let me just rewrite the equation down here so that we can get a good look at it. All right, now let's plug in what we know. So S sub 40, because n is 40, is equal to 40, once again, because n is 40, times 2 times A1, which now is negative 11, plus our D, which is negative 6. Notice that I put negative numbers particularly in parentheses, mostly so that I don't have like signs like a plus and a minus right next to each other. It doesn't really matter, but it just makes it a little bit easier to see. And then 40 minus 1, because our n is 40, all over 2. Okay, now let me plug that in. Which gives me that S sub 40 is equal to negative 5,120. So sums can be negative. That's totally cool because most of the, in fact, all of these terms will be negative, which means when we add a bunch of negative numbers up together, our sum is negative. That's fine. It's not wrong. Totally right. Okay, so now let's look at that last example. Oh, sorry. The last example has this funny symbol on it. It's called a sigma. It's a Greek letter called sigma. And we use sigma to signify a sum. And so when we look at this, the way that I want you to think about it is we want the sum of this equation that's on the right-hand side, this 9k minus 13, but we want the sum from 1 to 11. What that means is that we're potentially what we could do is plug in the number 1 into my equation, get an answer, then plug in number 2, get an answer, plug in number 3, get an answer, all the way up to plugging 11 in and getting an answer, then taking all of our answers and adding them up together for our final answer. So that's one option. Totally good option. I have no problem with that. But we can also, it might take a little bit of time. So instead, what we're going to do is use a formula that from up top. The formula I want to use is this one where it's n times a1 plus an all divided by 2. So now n, in this case, n will always be this top number. Okay, that just means that we're going to have the first 11 terms. Totally cool. Now to find a1 and an, what we're going to do, a1 is just when I take my equation, that 9k minus 13, and replace the k with 1. And then my an is when I take that equation, the 9k minus 13, but replace the k with my n, which we just decided was 11. So now my a1 has to be negative 4, and my an has to be 86. So now we have all of this information. We have a1, we have an, and we have n, which means we can plug it into this equation. So I'm going to say S sub 11, because we know our n is 11, is equal to n, which once again we just decided was 11, times a1, which is negative 4, plus 86, because that's our an, all over 2. And now let's just plug that into a calculator, which gives me that S sub 11 is equal to 451. Okay, and there we have it, how to use find sums of arithmetic series.